Good afternoon, everybody. My name is Evan Mather. I'm the past president of the ASLA Southern California chapter. Thank you, everyone, for taking the time out of your day to join us for today's webinar. I'm so happy to have everyone here today as head of our chapter's Climate Action Committee. I think today's webinar is particularly insightful and relevant. It's entitled Tools to Protect Biodiversity and Future Climate Resiliency. Before I go any further, just a little context that this presentation is very timely because we're currently planning a chapter level event on Earth Day, a climate action symposium on April 22nd. It will be held at Magic Johnson Park in the Willowbrook community of Los Angeles County. And with that, I'd like to introduce our two fantastic speakers today. Cheryl Lough is a principal with Pond Landscape Architecture, and she's also an instructor at Cal Poly Pomona. And Daniel Martin is a landscape architect, and he's also a consultant with Esri. And just for some clarification, he is not a coder, okay? But he's in their professional services department, and Daniel will explain more about what that means in a few minutes. But with that, I'm ready to hand it off to Cheryl and Daniel, and thank you everyone for coming this afternoon.
Thanks, Evan. Yes, we're going to jump in pretty quickly here and get going because Daniel has a lot of information and exciting information to cover for us. But Daniel, I did want to start with a quick question for you as we proceed into this. Many people are excited about the possibilities associated with this. And I was curious, what was the inspiration and the process behind the development of this program?
Yeah, thanks, Evan, and thanks, Cheryl. So CA Nature was originally kind of driven from an executive order from Governor Newsom, which directed the state to conserve 30% of the land and water resources for the purposes of biodiversity by 2030. And so that was kind of given off to some of the agencies to figure out how to make it happen. And then where I sit in Esri, professional services was actually brought in as part of the team to do so. So I'll kind of talk a little bit more detail as we get in here. But when Esri started in '69 with Jack Dangerman, it was really a consulting firm that was doing landscape architecture and planning. And as they were working through their projects, they developed geospatial tools to help them make better designs and better decisions. As they were doing these projects, they'd leave their software behind for clients, and then sometimes the clients would want to continue to iterate on that. And that was really the genesis of how GIS and ArcGIS as we know it today happened. And so now that Esri as a software company has grown, but that core work of professional services, the people who are domain experts in whatever it is. So for me, landscape architecture, natural resource management. For others, it's transportation or global shipping or all manner of other things that they work with professional services and our clients to do. So we were brought in as part of the project team with California CNRA and a few other agencies to support this 30 by 30 project.
Fantastic. Well, we'll let you go ahead, get ready to share your screen and get started. I just minor housekeeping. Remind everyone that might not be familiar with this portion of Zoom. There is a separate tab from chat for the Q&A. And so please feel free to post your questions throughout. And then at the end, we'll pick up and we'll start hopefully addressing those with Daniel. Thank you.
Awesome. Everything coming through okay on your side? All right. So I'm going to just jump right in here. So I had started talking a little bit about this with the executive order and the team. So under principal collaborators, you see California Natural Resources Agencies, Department of Conservation, Department of Fish and Wildlife. These were the ones that were kind of the tip of the spear in figuring out how do we implement 30 by 30. And those were the ones that I worked as the project manager for Esri with very closely for about a year and a half. It sounds almost too easy. Well, just conserve 30%. But as you start picking that apart, there's some components that quickly come to the surface, like where are we now? How much is currently conserved? What counts as conserved? Is there some sort of durability or permanence to it, or is it just not going to be developed right now? And what is the data that is used to make all of these decisions? And how do we loop in all of these different regional stakeholders in charting this plan and making these designs, especially since California is so very different and so broad, with different types of environments and different types of economies throughout the state. You could imagine that the big easy button would be, all right, we're going to draw a big polygon in the middle of the desert, conserve that 30%, and we're done. But that really isn't the intent behind this. The intent is to drive biodiversity as well as increased access for the public and climate resilience. And so how do we make these decisions in kind of a logical way? So our initial vision tried to simplify all of these things into the idea that there's data, there's maps that show that data, and then there are applications that allow you to perform analysis or make decisions. And these all needed to be integrated in kind of a seamless platform. This is a broad diagram here that is the CA Nature platform. I could spend a lot of time talking on this, but I'll just kind of discuss the principal components. So at the core of it is a geographic information system. That is the data and modeling environment. It is where things are updated. It's where the applications are developed. It uses ArcGIS Online as well as desktop, and brings in data from all of the state agencies. One thing, and we'll move to the next point here, the best available data, is that when you look at the entire state of California, the data resolution or the quality is not the same everywhere. Some areas have really granular quality data on biodiversity, but it ends at the county boundary or it ends at a reserve boundary. And so any insights from that can't necessarily be extrapolated to the entire state. And so having authoritative and statewide data sets to start was really important. And the state worked really hard to find what are the best in class data sets from all of their various different agencies that could be elevated to be included in this platform. Esri's Living Atlas also has a lot of data that can be piped in very easily, and it is authoritative and updated. So we were able to benefit from that resource as well. Thinking about planning applications or applications that would ingest this data, we were trying to capture what are the types of workflows and prioritization and things that would be valuable for the end users. The state and CNRA, they really envisioned this as being a resource, not just for themselves at state level decision making, but also for regional, local governments, commercial enterprises, individual citizens that are interested, nonprofit organizations, and anything that I just forgot. It's really for everyone. And so they're trying to kind of find a balance between here's lots of applications that do many different things, but we're also not being prescriptive. We understand that conservation and the workflows necessary to drive that are different in different regions of the state. So part of the capacity building is not only did we work with the state to grow their to grow these resources, and now we've added new applications to their kind of toolbox, but we also built training documentation that is part of the end site for anyone to go in and follow the user guide to understand how to interact with this data, what's the appropriate uses of that data, how do the apps work, and what does it actually show you. And then finally, everything was envisioned and currently is open access. So the hub page, which looks like a web page, but it's actually a geospatial app that is open to anyone. And there's also open data hookups so that all of these data sets that the state gathered can be brought into your own desktop analysis or your own applications to be able to leverage. So in just a moment here, I'm going to hop in and we'll take a drive through this platform. But there's one thing I wanted to speak a little bit about, which is the gap analysis project. And we call them gap codes. This is from USGS, and you might have heard of PAD-US. So that's the Protected Areas Database. These are a series of parcels that are national, that are all areas that are conserved and protected from development. So a subset of PAD-US is the California protected areas. And each one of these parcels or holdings has a code associated to it, either status 1, 2, 3, or 4. And this becomes really important as we start looking at the data, because that was the basis for what the state used to determine whether something was conserved or not. So a gap status 1 means that there's permanent protection of that parcel, and natural disturbance events are allowed to go and proceed. Status 2 is it still has the same legal protections, but there is some reason in that the management plan of that parcel prevents natural disturbance. Status 3 is areas that have permanent protection from conversion, but there's certain extractive uses that might not always overlay well with biodiversity. So my favorite example of that is national forests. I mean, they're a great resource. We know that there's lots of biodiversity there, but we can't say that every single square foot of national forest is purely for the purposes of biodiversity, because there's other really important uses that those lands serve. And then status 4 is there's no public or private institutional mandates. So there's no management plan. We know it's conserved, but there's no durability to that conservation. There's nothing that says that it couldn't be removed from the pool down the line. So I wanted to just talk briefly about that because it does come into play here. And now I'm going to jump over to the CA Nature website. So like I said, this looks like a website, but it's actually a geospatial application. This is the address, californianature.ca.gov. And this is the home page for both the 30 by 30 plan and the CA Nature technological components. So the state has now taken full ownership of this. They're updating the site with expo series and resources and things as they continue to go from now towards 2030, right? What we built is just the framework and the tools to get there, but now starts the work of following that pathway. But they have all sorts of announcements in here and resources and even links to the final pathways strategy. There's also a what we would call, this is another GIS app. It's a story map, and this really walks the users through kind of what I just described, but in a little bit more detail. What is 30 by 30? Where did it come from? And what does it mean? So we can see, here different countries that have been signing on to 30 by 30 and the story around why that's important and how there's follow-on benefits to conserving biodiversity, such as access to the public and resilience towards climate change. So I'll leave that there and start hopping around a little bit on the site here. There's a ton. So I'd mentioned that there was really robust stakeholder engagement. This was done as part of this 30 by 30 strategy. So you could kind of see that there's two efforts here. There is the state-led 30 by 30 strategy, which is the document that leveraged all of this deep feedback from multiple regions throughout the state in what their current what the current picture is for their landscape, for their populace, what are their challenges, and what do they need to move the needle to help conserve and help kind of grow sustainably. So that is all recorded in this 30 by 30 strategy. And then CA Nature can be thought of as the technological framework that helps to put rubber to the road. But everything is documented on this website. You can dig back into the topical summaries and feedback from different places. Now, every time I go here, there's new things. So just in the last few weeks, funding opportunities is a new section that is dropped on here. So you can start exploring what are the funding opportunities associated with CA Nature and with the 30 by 30 goals. There's also opportunity to get involved. There's the partnership for 30 by 30 and various different groups that are working with CNRA and the ability to sign up to be a part of that if you so choose. There's all the contact information and open data. I had mentioned, I'll just click on this really quick, but I'd mentioned that all of the data can be accessed in your own environment, whether it's your own ArcGIS Online, your own GIS desktop, whatever workflows you're currently using for landscape architecture. If you're bringing in data, these data sets around access and biodiversity and climate, these can be brought in alongside that. So I'm going to now hop over to the CA Nature tab and start diving into this data and the applications. So if I start scrolling down, quick spoiler, this is where we are. We're at about 24% conserved of the terrestrial environments of the state and about 16% in the marine environments. And then these next charts start to describe the other elements that go along with this. So 46% of the state is currently open to the public. That's quite remarkable. Then you'll also notice here is where we see these gap categories for the first time. So you might recall that gap 1 through 4 determines how preserved that place is. The end result of the state working through what defines conservation for 30 by 30. That's kind of an important thing to address here. Is gap 1 and 2. The reason it's important to kind of underline that is that the state recognized, and we all being professionals kind of recognize that just because something doesn't necessarily count as conserved or isn't a gap 1 or 2 doesn't mean it's not providing a lot of biological and ecological benefits. There's all sorts of green infrastructure, there's all sorts of sustainable farming practices, nature-based solutions and things like that, which are moving the needle, but they had to kind of find a place to demarcate for right now as the data and science progresses. And so for the purposes of 30 by 30 accounting, this gap 1 and gap 2 are the areas that count towards that 30%. So I'm going to kind of quickly zoom past here, but these are all story maps, user guides for the different applications, background information about CA Nature, and are really kind of useful for orienting how to use this data and these applications. The next tier is what we call the Explorer applications. These are the ones that are taking that authoritative statewide data and visualizing it in new and meaningful ways. And then finally, we have the Conservation Opportunities Modeler, which allows you to actually suss out where are areas that should be investigated for different types of conservation action based on the priorities that you input into the tool. And I'll loop back up to those in just a moment, but before I do, I wanted to just go to this gallery app to share a sense of what these layers kind of look like. So there's a ton of these layers. Each one of these is integrated in the applications in one place or another. And you can just at a high level explore these. So if I turn on species biodiversity, this is a data set from Department of Fish and Wildlife, which is one of many within what's called areas of conservation emphasis. So these are all, it is a hex grid that is overlaid over the entire state and has key biological information, everything from how connected is that, how much species richness is it, is there the prevalence of protected species in that particular cell. So this is all ranked 1 through 5, 5 being the most critical and important. Similarly, also from ACE is the aquatics data. And this is just one example layer of that aquatics data, but you'll notice that rather than being a hex grid, these are watersheds throughout the entire state, and each one is symbolized based on its criticality, right? So for here, this is aquatic significant habitats, and we can see, I just happen to know that the darker the color, the more significant it is. And so we have coastal areas and the delta. These are the most critical aquatic environments, and then some up here in the north coast. So that is a couple examples of biological data. This is one example of climate data. There's a ton of these raster data sets. Each one represents a different scenario, a different climate projection, a different variable, whether it's temperature, minimum temperature, maximum temperature, precipitation change, and different time frames. And these individual rasters are brought into the applications so that you can query them and get interesting information. And then finally, this is that GAP PAD US data set, which is the foundation for tracking and a key kind of opportunity. So these are taken at whole, that 49% of, or 46% of the state that is open access. This shows actually a little bit more because there are some gap coded areas that are not public access, say certain nonprofit organizations, but gives a pretty good sense. So let's go to these Explorer applications. First one I'm going to open up is the Conserved Areas Explorer. And this, what you're seeing here, is those GAP 1 and GAP 2 areas. We call this the state definition. You can explore these areas, and to get more information about it, you can click on them and get information. When the pop-up comes, it'll tell you what it is and any information that is available about it. So we say, okay, well, that's Death Valley National Park. Good to know. What you can also do is interact with all of these different charts. So if I wanted to say, all right, of the GAP 1 and 2 areas that is giving us about 23% of our protected areas in the state, which ones are actually owned by the state? And now clicking this button instantly filters all of these to show me which are now, it's building out that query, which are GAP 1 and 2 and are state owned. So you can also filter by the county, filter by climate regions, and filter by ecoregions. And each one of those, you can click on these different tabs to be able to say what is the relative conserved area as for that selection. So filtering for Butte County, I can see that actually only about 5.45% of that is conserved of the entire county. So I'm going to back out just a little bit, and you might recall that there's also gap 3 and gap 4. So if I go to custom selection, this brings in those additional gap 3 and 4 areas, and allows people to kind of drill in and understand that. So if I wanted to say, just look at gap 3, these are areas that potentially could be easy swaps, low-hanging fruit, for example, areas that are already protected, but maybe don't have a management regime in place that qualifies to kick them into a gap 1 or gap 2. So there's a lot of federal land, but there's also state and county land, city land, and a few others that can be filtered through and explored. And maybe a county might want to know, where are the areas in our jurisdiction that are gap 3, and does it make sense for us to investigate putting that into a gap 2 or a gap 1, and really building that out as maybe a project, a park, a biodiversity reserve, and opening that to the public and having some resilience built into our community. So there's a lot that can go in here, and we have limited time, but it really is helpful to explore that kind of starting point of all of these different holdings. I'm going to hop over to the next one. This is what we call the Access Explorer. And what we did is each one of those holdings of the gap 1 through 4, those conserved areas, we buffered that by a half mile, which is a walkable distance. And then we enriched those polygons with the demographic information that would be underneath them if you're looking at them stacked. And so what this dashboard does is summarize census information in those park sheds, if you will, the areas themselves, as well as the half-mile buffers. And so what you can see is, right off the bat, in California, 80% of folks live within a half mile of some sort of conserved area. But we can also click here to gap 1 and 2, which is what we're considering conserved, and that number drops to only 6%. So we can immediately see that, yes, most people have access to some sort of open space, but very few have access to what is considered really high quality habitat. And so maybe there's an opportunity there to put in a new project, to design something. And that's one of the areas I think that our industry, landscape architecture, can really play a role. There's a variety of other information, from age to education to income, and each of these things can be filtered by county or city. So you can zoom into wherever you are and quickly get a sense of what these demographic indicators are saying in context of open space. The next one is getting into that biodiversity application. What this is showing is, of all the different types of land cover, so you could think of agriculture, barren, conifer forest, desert shrub. You could imagine a land cover map, a raster of the entire state. How much of each type of land cover is conserved, and what is the protection of that land cover? So for this example, we're looking at conifer forest, and you can see here, this legend is what's called a bivariate choropleth. So it shows area of high presence, low conservation, low presence, high conservation, as well as high, high, and low, low. And then each county is symbolized towards that. So we could see that, say, in the northwest of the state, there's a high presence and low conservation of conifer forest. And down here in more of the central and Sierra Nevadas, we have high presence and high conservation. So I can toggle this land cover on to actually see the cells, the land cover cells that are classified as conifer forest. And you can see it actually maps pretty well to these counties. So what this is showing here is that on a county level, 21% of conifer forest is conserved, and through the state. So you can also filter by county if there's a particular one that you're interested in. But it starts to tease out that idea that we don't want to just conserve all of one thing. We don't want to do that polygon in the desert and call it done, because that doesn't actually provide robust biological benefit when there's all of these different classes of land cover. Diving into the data a little bit more, here is all of these ACE layers, so areas of conservation emphasis from Department of Fish and Wildlife. And what this does on the left is show the different map themes, is what we would call them, of these areas of conservation emphasis. And then there's a area of interest that you can move around. And what the application does is it's reading what comes underneath this area of interest and is showing you how those cells compare based on the different map themes or the different symbolizations. So where I just landed here, you can see it actually has relatively good biodiversity, rank 5 being the best. It's about 24% of all the cells underneath that area of interest, but not a lot of significant aquatic habitat, and really it's not rated overly high on connectivity. If I move this again, maybe somewhere towards some of these darker cells, it's going to recalculate that, and then I'll be able to compare anew. I see here, this is really, 62% of those cells are high species biodiversity, really good terrestrial biodiversity, and this does actually have rank 4 and 5 connectivity. So the map is simply being symbolized by the one you select, but you're able to compare all of them at once. And that was something that has never been done before with this ACE data, and Department of Fish and Wildlife was really excited about being able to tease out some of the insights that this allows. I'm going to go back up to terrestrial biodiversity here and talk a little bit about these box plots. So these are attributes within the ACE layers, such as native vertebrate count or amphibian count, mammal count, rare birds, rare mammals, and it shows a box and whiskers of the counts of these or the currents of those things underneath this area of interest. And then the green dots are the statewide average. So what we see here is a native bird count in this area is not only relatively high, but it's higher than the state average. So if I'm maybe the Audubon Society, or I am a local group or individual who's wanting to figure out where is it that I can focus my efforts to try and help native birds, this shows as actually having a really high occurrence of native birds. And so any efforts there would be likely welcomed. I'll jump over to the next one now. This is the Climate Explorer. And what this does, I had mentioned there's all of these different raster layers, and each one of these raster layers represents a different variable, different scenario. That's an emission scenario, so RCP 4.5 or 8.5. There's a variety of different models that you can select from, and then different years. And so I can click a comparison. In this case, I've chosen maximum temperature, RCP 4.5 and 8.5. I've matched a 4-model ensemble for each, and then have looked at the 30-year rolling average from 64 to 2084. And you can see this is the resulting difference layer. I clicked on this map just north of LA here as well to populate this change over time. So what you can see here is that as we go through time, these two models and these two emission scenarios are relatively similar until we start getting into the middle of the century and they start diverging. So the more extreme being the 8.5, which goes up to what is that? About 85 degrees, whereas the 4.5 is 82. By clicking on the map and also hovering over here, you can see where are these areas on the difference map that are going to have different magnitudes of shift. So what we see here is that coastal areas are going to have be impacted less. Most areas are going to be kind of in the middle here, and these are the cells where that occurs. And then the highest impacted areas are going to be on the dry side of the Sierra Nevadas heading into Nevada. So this is a very, very complex application. It's really fun. When we were building it, we were all zooming in on where is our house and where's our parents' house and trying to figure out what it looked like under different scenarios, and where's the areas that are going to get less rain or more rain, so on and so forth. This application here is the sea level rise one. It's a relatively simple app. It'll load up and it allows you to see the sea level rise as you adjust different levels of rise, as well as storm scenarios. So a daily versus say 100-year storm. And then this one here, climate smart land management. I'm going to skip over that, but it essentially is looking at land cover as well, similar to the last one, but it is looking at what are the different types of nature-based solutions could be implemented in those particular areas. So actually, I think that we do have the time. I'll quickly let this load. I think that is kind of interesting for us here. So once this loads, what you'll see is I selected forests. And so then these blocks of text, these come out directly of the nature-based solution plan, which is one of those planning documents. And so I think that there actually is a really probably interesting work in here for our industry, because it's technical design solutions that could be offered for these different landscape types. So if you're looking, say, at grasslands, again, you can say that 9% of grasslands are conserved within the state. These are the ways that grasslands contribute to carbon neutrality. And then these are some of the climate smart management strategies that are implemented with grasslands. So each one of these tabs at the bottom is a different land cover type with the associated information about it. Again, similar to the other applications, we have the ability to filter by map or by region, selecting a county or selecting a climate region. Now I'm going to jump over here to the Conservation Opportunities Modeler. So all of those different layers that we just looked at, and there's a ton of them. Here they are and all in one place. They're all brought into this application, which uses what's called weighted raster overlay. And that is essentially a GIS version of like a Machargian overlay analysis. So each of these layers gets stacked up on top of one another. I assign a weight to them. And then I also look at the individual classifications within it and assign a score. And so that allows you to give a preference, or I like to think of it as a recipe for searching for the needle in the haystack. So in this example, I wanted to see where are the areas that are less than 1 mile from one of those conserved areas, where are the areas that are going to have the least increase in temperature. EnviroScreen is a application and data set put out by California OEHA, and it's really looks at pollution burden and community vulnerability. And so I wanted to also see give preference to areas that are more polluted and more vulnerable. And then I wanted to give some preference to areas that have a high connectivity within the biodiversity realm. And so you could then describe this as saying, I want to find a place that it has the potential to be really connected within the landscape fabric, which has troubles with pollution and vulnerability that need to be mitigated for and need some help, that tend to be a little bit more climate resilient. So the work that I'm going to do is going to be as durable as possible and is as close as possible to areas that are already conserved so that we can help with the economy of scale by creating more contiguous reserves. And so when you run this, it then symbolizes the map and shows you areas green being good. Those are the ones that are most likely to meet your, or they score the highest to your particular recipe that you created here. This can be run over and over. I used to do this analysis in desktop way back in the day, and it was one of those that every time you wanted to make a change, it would be a day, or at the very least a few hours, and then you would have to click the go button and walk away and come back to get your result. But now, because this uses a web service and a server on the back end to do all of the math, it goes really quickly. So I could say, well, I'm just completely uninterested in anything that has that is going to experience a high temperature shift, and then I can rerun that, and it's going to drop out all of those cells. Or I could add a new layer into the mix and rerun it. For example, I'll click here. This is the biodiversity tab. It's the same idea, but it has a subset of those layers, all the ones that are really focused on biodiversity. And so I might say that I would like to select conservation by gap code, elevation, impervious surfaces, and species biodiversity. Design that model. I'm going to assign a starting weight of 25% for each of these variables. Take a quick look at the classifications. So what this is saying is that I'm looking for areas that are not currently counting towards conservation. So by scoring gap 3 and 4 highest, they are going to come up in the result, and gap 1 and 2 already conserved are going to be the lower. Elevation. This is an example of where the state didn't want to put their finger on the scale at all, recognizing that depending on how this analysis is going to be used, there's no one elevation that is going to be of preference. So for the purposes of our analysis here, I'm going to say that we're going to look for areas somewhere around the middle elevations, and then we'll kind of dial it down a little bit, and anything overly high, we'll keep it listed pretty low. Impervious surfaces. So this basically is where is it paved and where is it not. So places unpaved get the most highest score. Places that are already paved get a low score. And then species biodiversity. Remember, this is the ACE data set. So a rank 5 is the most biodiverse. So that gets a score of 9. Rank 1 is the least. We give that the lowest score. Now I'm going to change the color ramp. So green means good. Click run. This is what used to take a day. And now the dark green areas are those that would warrant further investigation for any sort of project. So I think there's a lot of possibility here, and I'm personally really excited as we try and always stuff in as many benefits for health, safety, and welfare, but also for our clients. How can we bring more value to them by understanding the context that our projects exist within, and some of the resources and things that can be kind of connected to, whether it's from highly biodiverse areas or areas that are low public access and you want to bring in more access. We can just really kind of be able to drive these things more effectively, and in doing so, moving the needle for that 30 by 30 goal. So I'm going to hop back here. This is the open data site. There is a user guide for how to use it. It does get in a little bit into the weeds, but it's not overly complicated. You kind of just click in and can choose the layer that you want. But the other thing that's really interesting that I wanted to point out is this workflow here, which is request a conservation status review. So all of those parcels, that is kind of the first cut of it, gap 1 through 4. But the state recognizes that this is a changing and shifting field. And so if there's a project that you have, or somewhere you're aware of that you think should count towards that conservation goal, this is the workflow to fill out the survey and to point to it, and to then work with the state to get it included in that PAD US layer that drives all of this. So I know that was probably sipping through a fire hose a little bit, but I think we covered many of the high points. I will put, I'll flash up here my contact information. If anyone wants to dive in or chit chat more, I'm more than happy to talk this stuff all the time. But I think that's pretty much everything I was hoping to cover today.
Wow, thank you, Daniel. Please go ahead and drop some questions in the Q&A. I'll kick it off with a question. You provide your information so generously. Thank you for that. But are there additional training resources for the system, YouTube videos or something that can assist the user in navigating this?
Yeah, so a couple different ways to access that. So in each one of the applications, there's a help button. And when you click on that, what it actually does is open up the user guide. And we'll give this a second to load, but this provides all of the background information about this particular app. So it, rather than being a separate YouTube video or something like that, it is included just as a tab within that application itself, so you don't actually have to leave. And it has everything about the data, or even about how to use the dashboard, complete with with GIFs, animations, and explaining what all these things are, how you could use it, that sort of thing. It can also be accessed, if we go back here, I had mentioned that we scrolled through this at the beginning, but these are all of the user guides for the different applications. So that would be my my recommendation if you're interested in using one of them, or you might have a question on the data or how the application is doing this summarization. The user guides do a really good job of kind of walking you through that.
Oh, we've got some questions rolling in. Okay, so question, how would I determine the most effective strategies for a particular site that a client might have?
Well, I think most effective is a tough one, because it depends on the client and it depends on the type of project and the goals there. But off the top of my head, I think that at the very outset, looking at the Biodiversity Explorer to get a sense of what sort of biodiversity assets are there, and how that on a landscape scale, how it's rated. Is it considered connected? Does it have a high score for climate resilience already, or is that an opportunity to kind of move the needle? And then looking at the conserved area explored to see what are the other holdings that are nearby. I think that those are maybe two easy points to kind of start driving in to get a sense of what that site itself is looking like, as well as what maybe is in the immediate region that you could, through design interventions, daisy chain into.
Great. Another question that's come up is the data analysis is awesome and incredibly beneficial to understanding where we are forecasting 3030. What is the state implementing to respond to the findings of the data analysis?
Yeah, so I think there's a couple parts there, and the caveat is that this is me personally kind of taking some assumptions, because I don't work for the state and don't have control over their process. But there's two things that I can say is that over the next 8 years, they're going to continually refine this data, and there are other data sets that were nominated but were not ready for the limelight quite yet. And so there's going to be more data coming online, and as we bring in more data, then the accuracy and tactical opportunities will also increase. The other thing about that is that, you know, the implementation of going from where we are today to that 30 by 30 is not envisioned to be a top-down process at all. And these tools, you may look at them and say, wow, that's really broad, like the opportunities, the opportunity analysis with a weighted raster overlay, and you can choose from 60 layers, like that doesn't really give a clear sense of where in the state is going to be conserved. And that's kind of by design, because the state is trying to put this out there for the decisions of where are areas, say, that are gap 3, where do they get classified into a gap 2, or where are there large projects that are currently not considered conserved, but there's a landowner or a project owner who wants them to count as conserved. That is going to be grassroots from the ground up. It's going to be the regional governments, the city governments, the landowners who would opt in to be counted, that we'll see where these new areas pop up. But it's not like there's a prioritized list of every parcel in the state, and you know, this parcel scores the highest and is priority 1, 2, 3, and 4. While the data, you know, that technically is possible, it defeated the point of what the state was trying to do, which was to just provision local folks with the tools to make decisions that make the most sense for their particular community.
I'm going to combine two questions. I'm going to read both of them and then allow you to answer it because they're in the same vein. Excellent presentation and an amazing tool. Many thanks. Are we in California the lucky ones to have this resource, or are other states in the U.S. planning to add their data to the tool? Also, the UN's Biodiversity Global Summit is happening now in Canada. How does the 3030 California program compare to the efforts other states or nations have implemented to protect biodiversity?
Good question, and there's a lot there, and I appreciate the positive feedback also. So California is actually the tip of the spear as far as the US in putting together something like this. California's 30 by 30 efforts actually even predate the federal level 30 by 30, which is called America the Beautiful, which some of you may have heard about. So so really forward thinking, and it's exciting. Now, this particular platform is specific to California, but the tools, the like geospatial tools, are configurable. 80% of what I showed you today is just completely off the shelf anyone who has ArcGIS Online already has, like this is a dashboard. And so anyone could configure these same sorts of things in the same way with data in their own state. We do see interest from other states in following suit and building similar sorts of platforms for their own stakeholders and residents. But California is the furthest along by far. And then I think followed probably by the federal government with the America the Beautiful. They have a platform that they put together, but it doesn't go into the detail with as many exploration apps or the decision support apps yet. As far as the UN meeting, I do know that 30 by 30 is gaining a lot of traction, and it has been over the last year or so. And so there are a growing number of countries who are signing on for the 30 by 30 aspiration. And it is kind of remarkable that California is the leader, a state is the leader in a group of, last I checked was 80 or so countries. So I think each one has kind of their own starting point, similar to just how every state is going to have their own starting point for putting this together and determining what are their conserved areas and that sort of thing. But there's certainly going to be there's synergy as more and more folks kind of come to the table and chart this path forward.
Are you familiar, Daniel, with any firms or institutions that are currently utilizing this tool on a particular project?
Not yet, but I'm hoping that maybe someone on this call might be the ones. You know, this was only released. It was released, I believe, in April or May, so it's relatively new, and we see kind of a slow growth as people are ramping up, but I'm not sure how many folks in kind of the commercial and project world are aware of it. I know that that ASLA, the California ASLA, wrote a letter as part of the feedback supporting the pathways in the 30 by 30, but to my knowledge, this is the first time that we've kind of talked about the end result of these tools. And so I think there's a lot of potential in using these in a project, and and I'll keep my ear open for that. And if anyone has an idea, I'm more than happy to brainstorm on that from my perspective to see how we might be able to harness some more value for our clients and for the public.
Well, that's about all the time we have. Thank you again, Daniel. This is fantastic. I think I speak for everyone on the call when we're all excited to see where this is going to lead. This is a plethora of information that I think can be utilized greatly across the board. Many different professions we're going to see overlapping here and gathering and acquiring some of this data. Any final closing statements you'd like to make here for us today?
You know, I thank you all for carving out the time to listen to me ramble. And thank you, Cheryl and Evan and Vicky, for putting this all together. This has been a lot of fun. I think that you know, the only thing I'll end with is that I really do, I sincerely mean it. If anyone has would like to brainstorm around how do we put the rubber to the road on this stuff, I'm always happy to do so, and love this stuff, like getting into the weeds and working with it. So please reach out if there's anything I can do to share some more information about this. And otherwise, I hope everyone has a good rest of the Friday and a good weekend when it gets to them.
Great. Well, thank you. And thank you all for joining us today. This has been recorded, so the video will be available via the ASLA, and you can look for that information. Maybe Vicky can send out a little bit of a link or something too as well. Thank
All righty,
you.
thanks.